Hello. Today we will find out how and why hypertonic decontamination improves chemical risk management. Why should you use a hypertonic solution to rinse your eyes? In fact, the key term in the answer is osmotic concentration. You've probably already heard about the drinks specially designed for athletes, the so-called isotonic drinks. They contain ions, or as athletes say, electrolytes. These drinks restore these electrolytes to our bodies after physical effort. The ions, or molecules, move through the liquid and make contact with the container. They apply pressure to the container. This is the osmotic pressure, otherwise known as osmotic concentration or osmolarity. Our body also contains ions and molecules. It therefore also has an osmotic pressure. If a liquid has the same osmolarity as our body, it is isotonic. If the osmolarity is lower, the liquid is hypotonic, and if it is higher, it is hypertonic. What does this characteristic mean for a liquid? Let's do an experiment. I will fill a glass with tap water. There are very few ions, so the osmolarity is low. Next to it, I will fill another glass with seawater. This water contains sodium chloride. Of course, it contains many more ions, sodium and chloride ions. Therefore, the osmotic concentration is much higher. Then I connect the two glasses with a membrane through which the liquid can pass. What will happen? The answer is quite simple. Nature balances the osmolarity in the two glasses. The liquid moves from the glass with the lower osmolarity to the glass with a higher osmolarity. This process continues until a balance is reached. This phenomenon is also used to produce tap water from seawater. For desalination, reverse osmolarity is used with special membranes. Let's get back to the chemical contamination in the eye. Our bodies have an osmotic concentration of about 0.4 osmoles per kilogram. Now consider a sodium hydroxide solution. Sodium hydroxide is rich in sodium and hydroxide ions. Depending on the concentration, the osmolarity varies between 1.8 and 2 osmoles per kilogram. Unfortunately, I get splashed with this chemical in my eye. The concentration of ions in the contaminated eye increases, so the osmolarity rises to about 1.4 osmoles per kilogram. I start to rinse as quickly as possible and use the safety shower with tap water. However, the osmolarity of tap water is quite low, about 0.1 osmoles per kilogram. So I put liquids together that have a very different osmolarity. Remember the two-glass experiment? Even in the case of this accident, nature will balance the osmolarity of the two liquids. But here the difference in osmotic concentration between the eye and the water is immense. 1.4 versus 0.1. Many water molecules enter the cells of the eye. Because there is little space to accommodate the water, the cells of the eye will eventually burst. This is what doctors call osmotic shock. To support this, we will show a video. Ophthalmologists incubated endothelial cells from the eye at 0.8 osmoles per kilogram and then put them in contact with tap water. You can see how quickly these cells burst. You can also observe this phenomenon when you take a shower or spend a long time in the pool. Your fingers will get soft and wrinkled. For your skin, this is not as problematic. Cell regeneration is quite fast. However, our eye cells are much more sensitive and can suffer irreversible damage. This is why ophthalmologists recommend, after a chemical accident to the eye, to rinse at least with an isotonic solution, or preferably with a slightly hypertonic solution. This way your eyes will return to normal more smoothly, and you will avoid an osmotic shock. We hope this explanation is helpful. And of course, we remain at your disposal for any questions concerning prevention and safety around chemicals in your workplace or at home. Thank you, and see you soon.